All right, this is lesson 4 from module 1. We're going to talk about unit rates and constant of proportionality. So, a couple points to remember. A proportional relationship is one that has a constant ratio or unit rate. So that means the unit rates are the same. That's a proportional relationship. Now, this constant ratio, or what we call unit rate, can also be called the constant of proportionality. We learned that in lesson 3. We can also call it K. All right, let's look at example 1. This is all going to be review from lesson 3. It says wildlife conservationists are concerned about the deer population might not be constant across the national forest. The scientists found out that there were 144 deer, 16 square miles, and in another part it was 117 deer and 13 square miles. A third one found that it was 216 in, I believe that's 24 square miles. So do conservationists need to be worried? So what is the population density of deer per square mile? So that's talking about how many deer per square mile. It's telling us we have to find the unit rate. So here's my label for my unit rate. So let's take the first one. We have 144 deer in 16 square feet. So I'm going to bring my calculator into this. We're going to do 144 divided by 16, and that gives us 9. Now, if I talk about the second person, is 117 and 13. So 117 divided by 13 is also 9. And the third one is 216 over 24, which is also 9. So the unit rate is 9. Now, what is the constant of proportionality? Well, remember, the constant of proportionality is K. It's the same thing as the unit rate. We already found the unit rate to be 9. So what does this mean in the problem? We'll use your label here. That means that there are 9 deer for every 1 square mile. So what is the equation that represents this? Yesterday we learned that the equation is y equals kx. So if we know k is 9, then the equation is y equals 9x. All right, let's go to the next page. Let's use the unit rates, y over x, to determine how many deer there are for 207 square miles. Now, if you go back to the page before, the square miles was on the bottom, so that would be our x value. So we have y equals 9x, that's the equation. 207 is my x value, so 9 times 207, I can do that on the calculator, is 1,863. And that's how many deer there are. All right, let's use the same unit rate, same equation, and let's find out how many square miles it would be for 486 deer. That's your y value. So same equation, y equals 9x. If I have 486 deer, I'm going to divide both sides by 9. So that cancels out, and I have 486 divided by 9 is 54 square miles. So that's all the stuff we did yesterday. Let's keep practicing this. Let's go to the next page. Example 2 says, Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade level. He needs 3 cookies for each person, and there are 96 students. Unfortunately, he needs the cookies the very next day. So Brandon and his mother determined that they can fit 36 cookies on 2 cookie trays. So is that a proportional relationship? Now remember from the first page, proportional relationships are when all the unit rates are the same. So let's start off by making a table. We are going to put the number of sheets, number of cookie sheets, and how many cookies can be made. So that information is in the word problem. For every 2 cookie sheets, you can make 36 cookies. So if we add, that'd be 72, and you can keep going with that. So the unit rate, we're going to do y divided by x. Now your y value is your cookies. Your x value is the number of sheets. All right, so we have 36 cookies on 2 sheets. So if I do 36 divided by 2, I get 18. So that's how many cookies can fit on 1 sheet. So the unit rate we found was 18. So what's the constant of proportionality? That's the same thing as the unit rate. We just found that. So K is 18. So what does this mean? Use your label. It means that there are 18 cookies on every 1 sheet. So write the equation. Remember, it's y equals kx. We know k is 18. So that makes my equation y equals 18x. Harpy says if it takes 2 hours to bake 8 sheets, they begin at 4, when will they finish? All right, well, let's figure out how many sheets she needs. Okay, there are 3 cookies per student, 96 students. So the total amount of cookies that she needs, let's do 96 times 3, is 288. That's total cookies that she needs to bake. Now there's 36 on a sheet, so let's divide that by 36. So 288 divided by 36 means she needs 8 sheets total. So it's going to take 2 hours to bake 8 sheets. I'm sorry, that's wrong. Let's not do that. Why I'm hesitating. Let's try this again. Let's figure out how many sheets she needs, and we're going to do it using the equation. Y equals kx. Y is the number of sheets. That's what we're trying to find. I'm sorry, Y is the number of cookies, which is 288. K is 18, and X is the number of sheets. So now I can find how many sheets she needs by dividing. So 288 divided by 18 is 16 sheets that she needs. So she needs 16 sheets. We could have done 288 divided by 18 instead of 36. All right, so if it takes 2 hours for 18 sheets, she will need 4 hours for 16. And if she begins at 4, that means she will finish at 8. All right, let's go to example 3 on the back. It says Suzette and Margot want to prepare crepes for all students in their French class. The recipe calls for 20 crepes with a certain amount of flour, milk, and 2 eggs. The girls already know they have plenty of flour and milk to make 50 crepes, so they need to know how many eggs that would be. So considering the amount of eggs necessary to make the crepes, what's the constant of proportionality, our K value? So we want to know K, which is Y divided by X. Now, the number of eggs is going to depend on how many crepes, so we're going to put eggs over crepes. So there are 2 eggs that will make 20 crepes, which is 1/10, and that's our constant of proportionality. What does this mean? This means that you will need 1 egg for every 10 crepes using your label here. So you will need 1 egg for every 10 crepes. So how many would you need for 50? Well, 1 egg for every 10, and there's 5 sections of those, so you need 5 eggs. All right, so let's sum this all up down at the bottom of the page. It says, what is another name for a constant that measures the two quantities? Well, this is the unit rate, which we also call constant of proportionality. And how is the constant of proportionality related to the unit rate? Well, they are the same thing. All right, go ahead and try that problem set for homework tonight, and we will go over it in class tomorrow.